10 years old. Turns out I really liked it. And I kept going with it, and eventually I decided this is something that I would like to do for the rest of my life. I'm not sure if you guys have found something like that yet, but don't worry about it. As long as you find something in the end where you know this is something that makes you happy and something that you enjoy, it's great. So I found this with computer science, and I also found it with sailing. And also when I was 10, I started sailing, and eventually I got to boats like these. So that's a ton of fun. And when I came to UBC, I found that SailBot, this thing right here, was a perfect combination of the two. So this is an example of some of the programming that we do for SailBot. Anyway, now to talk about that. So what we do is we build self-driving sailbots. I'm sure you've heard of sailboats. I'm sure you've heard of self-driving cars and many other things now, UAVs, tons of cool stuff, but never sailboats. Why would you have something like that? Well, this is what we make. This picture here doesn't have the sail on it, but it's a 5.5 meter long sailboat, and it's basically a proof of concept that you can make something an autonomous sailboat that doesn't use power from external sources to cross the Atlantic Ocean. That's a pretty big feat, and if we get it right, then we can take a lot of technology from this and put it to the industry uses, so like the shipping industry, and really impact the world that way. Anyway, how do we do this? It's easy. With artificial intelligence, right? What could be hard about that? This guy, I don't know if you recognize this. Yeah. That's a different kind of AI. Hopefully we won't use that. What makes a sailboat autonomous is, well, first off, an autonomous agent is one that can act intelligently in a certain environment. So our agent is a sailboat. It can sail properly. It doesn't have to be able to think like a human. In fact, most of the time, intelligent agents have a very simplistic view of the world, and they turn out to work quite well, as I'll tell you. Yeah. So how our system works is it works in 3 levels. First, we have detection, so finding obstacles in the world. Then we use route making to find a path around said obstacles, and then we send it to control. So that's how we actually sail. So detecting obstacles, it's not easy. It has 2 components. One is called AIS, which is an autonomous automatic identification system, and it allows us to know the position of every ship in the world whenever we want. So this is a map of Vancouver, and as you can see, we have the locations and information about every ship around. The next is thermal imaging. You've probably seen it in military use, and basically it shows a heat map of whatever's in front of the camera. We use this to detect ice and logs in the water. So it's a little bit different than the military use, but it's still quite advanced. This is our testing mock-up. As you can see, there's a lot of technology in here, but the camera is roughly this big, pretty small. So what this allows us to yeah. So this is a video of thermal imaging as we approach a buoy. So as you can see, this picture would be the same if it's at nighttime or daytime. It doesn't matter. We can see that there's a difference in the temperature of the buoy versus the water, and that allows us to detect it in the fluid and avoid it accordingly. So how do we avoid it though? That's where the next component. Skip that. So let's say X, the get an idea that maybe there's something here. So we mark it. And then as we get closer, we know there's a better and better idea that there's something in this direction. And so we keep marking that. And eventually we're like, okay, well, we know there's a fair amount of danger there, and we avoid it, and eventually we know exactly where it is as we move. So this system allows us to detect obstacles. It doesn't matter if it's 1 or 10, we can avoid any amount of obstacles that we encounter. So there's a lot of technology behind this, but it's really cool stuff. And when you find a solution to a problem like this, it's incredibly satisfying. So that works on a small scale, so for like avoiding buoys, but we can also avoid weather patterns. So this is a simulation running from like the Caribbean to the east coast of the U.S., where we're finding the best path to avoid harsh weather patterns. So now we found the route to our location. Now we want to get there. So how hard can it be? Sadly, we can't just point at it and turn on our motor. Sailing has a bit of has some special restrictions. So in our case, if we really simplify it, we just can't point it to us. We just zigzag back and forth. Yeah, this is just one of the problems. And like as you Thanks. Sensor data. So an autonomous agent in a computer, it doesn't know what the world's like, right? All it knows is what you tell it. So in our case, we use sensors. So an important lesson that we've learned, and I can share with you, is that sometimes it's better to invest in good equipment rather than the cheapest stuff, because bad sensors equals bad sailing. So this is an example of some of the equipment we use. This is GPS antenna. Now, as you may know, your phone also has GPS, but that sensor is this small. This one is yay big. So cool stuff. When you join an engineering team, you get to play around with cool equipment like this. And there's a lot of challenges, but it's really fun to solve them. And as you're working with a team, you're constantly thrown new challenges, and you work together to solve it, and you become very good friends with these people. I highly suggest joining an engineering team if you decide to go into that field. And then how does this all run? It runs on a small computer called an M3 now. It's like $30. You guys can play around with it at home. This simple piece of circuitry that can steer a boat autonomously. It can fly an autonomous thing. You can do anything. It's pretty crazy. Just some like fun facts. This thing only runs our code 10 times a second, which doesn't seem very fast. But when you're working with computers, they can make the perfect decision every time. So 10 times is actually a lot faster than a human. Because let's say you're thrown different scenarios 10 times a second. Would you be able to make the right choice? Probably not. Yeah. It's some pictures of the equipment. It looks kind of complicated, but it's really not. And working with all this stuff, you learn to really respect technology. So some people get a bit scared, like, oh, it's really advanced stuff, it's super powerful. They're powerful enough to become our overlords, but they're really accurate, and you can do really cool things with it. I highly suggest that you guys try it out, because you can do some really fun stuff with it. Important, yeah. So it's fun. It's a great learning experience, but